Thank you, Pastor Matthew. If you didn't get my name, so here's the easy way to remember not my name. It's easy. My first name, real name is Lewis. My last name is Fitting. When you look at me with this flat top and so forth, you might say, that pastor's got a loose fitting. Most people don't forget that, so hopefully that helps you with my name. So what we're going to do is we're going to go ahead and have a word of prayer as we begin. If I didn't answer all the questions that you have at this point in time, then I guess you can write it on the card and ask it later. But let's have prayer, and then I'm going to introduce our speaker for the series. Father in heaven, we are so thankful to be able to host this series this evening. I know that this is a big question, Lord, that is being wrestled with even in this day and age. Creation, evolution, something in between. What is it? I pray, Lord, that you would be with each one of us tonight and help us to have, no matter what, where we're coming from, but Lord, I just pray that we would all have open hearts and open minds, be receptive, so that we can, from evidence presented, we can make an intelligent decision and a conscientious one for ourselves. So again, I thank you for all those that are here tonight, and we thank you for your blessings. In Jesus' name, amen. So our presenter for this series is one of our own from the Caldwell Church. His name is Ron Day, and he has had a fascination, I should say, an interest in creation and evolution and looking at it from a scientific point of view. And so without further ado, I think we're going to get started with our program this evening.
Where did everything on planet Earth come from? How did life start? How did humankind begin their journey on planet Earth? Hi, I'm Dr. Stan Hudson. I want to welcome you to this 6-part series on the subject of origins. And we're going to be addressing those big questions of where everything came from. Those are the kind of questions that I was introduced to when I was a geology major back at UC Riverside way back in the day. I was introduced to the great world of rocks and fossils and the theory of evolution as to how we got all those things. I wasn't completely happy with all the answers that I was hearing, and actually I was led into a new area, religious faith. Today we're going to give you some evidence on the subject of where we even have a debate on where everything came from. Why is there such divergent views if the science should support a single view? Partway through this presentation there will be another video in which I'll be joining you, and also other people that are scientists and religious leaders who will be addressing the topic of the day. That will be our format as we go through our series. Right now, we're going to turn things over to our local hosts. And again, we want to thank you very deeply for joining us on this journey as we take a look at the great questions of where everything came from.
Hello. Is my mic on? Well, hopefully shortly. Mine's on. Okay, we got it? Okay. Hello and welcome to the 6-part series of presentations on the controversial subject of origins. We hope these topics will aid your personal understanding of origins while examining the nature of the ongoing and often heated debate. Presentations are going to draw evidence from 2 models offered, science and scripture. We will differentiate the models, explain their historical roots and cultural roots, and the basis which undergirds the thinking of the different views. Tonight we're going to talk about the origin of the current debate. Hello again, my name is Ron Day. How many of you have noticed the tension over the subject of origins and where everything comes from? It seems that evident that science and religion are in combat. Now, we don't think it should be that way, but if we can understand where both sides are coming from to form their views, maybe we can understand a little better why those differences exist. You know, this subject has even inspired bumper stickers with symbols illustrating the conflict. Now, there have been polls taken in the United States called the Gallup poll. I'm sure everybody's heard of the Gallup poll. The latest one in 2017 asked Americans, where do you think we came from? 3 options were given. On the far left graph is recent creation, which is something more like a biblical view of where we came from. On the far right is natural evolution, that is, nature was sufficient for creating and organizing everything. And in the middle view is called theistic evolution, meaning God, using evolution, created everything to make new species and eventually human beings and the diversity of life as we see today over millions of years. The 2017 poll showed that 38% of the Americans favored a recent creation. Again, we would call that a biblical view, but that the world, or at least life on it, began just a few thousand years ago. You know, America still remains a fairly religious country. The theistic evolution number was similar at 38%. These believe that God is responsible for getting us here, but Darwin was right too as to the method. This group includes people who have a high view of religion and also a high view of popular science. And they try to make the two things work together. Finally, 19% favored natural evolution. That number is heavily influenced by young people today. For the last century, that number was closer to 10%, but now there's a growing trend among young people of today who feel that religion is the source for much of the problems and strife in the world today, and they seem to have some evidence to sort of back that up with. They have come to the place where they think that perhaps there is no God involved with us being here. Now, I know these numbers don't add up to 100% because, you know, some people didn't want to state their opinion. However, we rarely find people who don't want to state their opinion. The word science comes from the Latin word scientia, which means knowledge. Science is defined as a system of acquiring knowledge based on what is called the scientific method, as well as the organized body of knowledge gained through such research. Now, it's helpful to notice that there are 2 parts of the definition of science. First, there is hard science. This is the kind of science that you do in the laboratory. It's testable knowledge, something that can be observed and predicted. Hard science sometimes is interpreted using current models and a worldview. But again, it's something that is repeatable, something that you can see when you do experiments. In contrast to hard science is what we would call historical science. Historical science is not testable knowledge, something that can be observed or predicted. Historical science is a story trying to explain the past based on current processes and observations. Yet, it's not repeatable. You can't repeat, for instance, the Big Bang. So historical science always is subject to favored models and worldviews. Let me give you an example of what historians can do with what we call simple facts. Okay, pilgrims came to America in the 1600s. What were they seeking? Now, historians could write about this and say, oh, they were seeking to take land away from the Native Americans, or they were seeking religious freedom to escape the intolerance of Europe. Or it could be something totally different, or it could be all of the above. The historian's answer may tell you more about the historian than the pilgrims. Historians have worldviews that affect their interpretations. You know, if facts are facts, why don't we all agree on everything? Believe it or not, this actually is very difficult. You know, we don't all agree. We're not all Republicans or Democrats. We're not all religious or secular. We're not all highly educated in the sciences. We're not all theologians. We all have different views. One of the things we all need to remember is something that's very rarely taught or understood. There is data, the hard numbers, and then there's the interpretation of that data, making sense of the data that you're looking at. Data does not equal interpretation. There are two distinctly different things, and interpretation is always open for review. Let me sum it up. Hard science equals data. Historical science equals story. The subject of worldview is critical here, but first off, you're probably thinking, what is a worldview? Everybody has one. It's the faith framework we use to interpret or make sense of our world. It's formulated by where and when we were born, our parents, our education, our experiences and culture. All of these combine to give us a sense of meaning in this world. 5 questions will help us examine and understand our worldview biases. Number 1, what is your supreme authority? In other words, it's the place we go to help us understand something with a final answer. Who is the one that gives us the best authoritative understanding of what we're looking at? It could be science, it could be God, it could be many things. Number 2, where did everything come from? And that is origins, right? Number 3, what is your place in this world? What space do we occupy in this vast universe? What role does our understanding of life play in answering this? Our worldview will inform this. And number 4, what is your moral code? What is right and wrong? What are the great moral issues of the world today? Who are the good guys? Who are the bad guys? The good forces, the bad forces, and all that. The moral code will identify them. And number 5, what is your future? Where are you going to end up is a very key question. All of these things will contribute to the forming of your worldview, and this filter will help you interpret the data. Now, here's another example of a worldview how a worldview clearly interprets data. Now, if you go to the John Day fossil beds in National Monument in Oregon, and no, we're not related, you can see some marvelously preserved fossil beds, mostly of mammal fossils. These fossil beds were first studied, written about, and promoted in the 1800s, greatly increasing the nation's understanding of life by Oregon's first state paleontologist. And he was a Christian minister. His name was Thomas Condon. And this is what he wrote about the fossil layers he saw. The hills from which these evidences were taken, he wrote in reference to the evolutionary record of the fossil beds, were made by the same God who made the hills of Judea, and the evidences are as authoritative. He added, the church has nothing to fear from the uncovering of truth. And he also said, evolution was simply God's method of working, and therefore not atheistic or infidel. Obviously, he understood the biblical account of where everything came from and the story of the flood. Plus, he had an understanding of the modern theory of evolution and interpretation of fossils in his day. We could reasonably ask, what was Thomas Condon's supreme authority? That was the first question we asked under worldview. In other words, when science and the Bible conflict, what was his supreme authority? Even though he was a minister, his supreme authority was the popular science of his day. Our worldview helps us interpret a lot of things, our understanding of suffering, our understanding of wars, our understanding of where things came from, and a whole host of other things. It will be helpful in your understanding of science and faith. Our worldview informs us of what we ultimately believe in the origins of the earth, perhaps even some of the intricacies of which came first, as well as what we believe about the great questions of pain and suffering in the world today. Question: do you still have a place in your worldview for God? What does he look like? And how does your worldview help you come up with that picture? In 1998, a poll was taken of members of the National Academy of Sciences. Now, these are the people who put together the curriculum that is studied on the subject of origins in our public school system. A poll was taken of their beliefs. It revealed their worldviews. They were asked, do you believe in a personal God? Only 7% did. They also asked about disbelief in a personal God. That is, are you certain he doesn't exist? The answer was a full 72% disbelieved in a personal God. 21% had doubts and didn't particularly want to make a final statement. So a full 93% of those thought-leading scientists, and actually as the title of the article says, leading scientists still reject God, rejected God. It's logical to assume that their worldviews would influence their approach to origins and their interpretation of the data. But ironically, Western science had its roots in a different worldview as people were motivated to study nature as the works of a creator God. The great early scientist Isaac Newton said, no sciences are better attested than the religion of the Bible. He saw no conflict between believing in a creator God and trying to understand and interpret the things seen in nature. Where, when, and how did this change? Since the 1200s, universities in Europe, like Cambridge here, only taught God had created the world like the Bible said. And for centuries, all the graduates tended to think the same as their professors. However, in the last couple of hundred years, today's universities in the West only teach that nature, material, created and organized everything that we see. In other words, nature was deified and personalized in the storytelling of science. And now, most all graduates tend to think the same as their professors. Science operates using models which are difficult to change. You would call them theories, but they are operational models. They are meant to help us understand what we see. A pioneer in the subject of changing models or theories was Harvard PhD physicist Thomas Kuhn. In the mid-1900s, he wanted to understand how models change in science. For example, he wanted to see if he could understand the way the Greek philosopher Aristotle interpreted nature. He wanted to get into Aristotle's mind and see reality as Aristotle saw it. It took a while, but eventually Thomas felt that he had arrived there. But then he went to the next logical question, and how did we get from Aristotle to here? There had to be some serious model changing along the way. How do you change large models like that? So Thomas wrote a book that became quite influential in the philosophy of science. He called it The Structure of Scientific Revolutions. He basically said that scientists operate using models, and they are indeed difficult to change. In fact, he came up with the concepts of paradigm and paradigm shift. It's hard for scientists like everybody else to shift their paradigms, to change their models, their theories. It received a lot of criticism, especially from the scientific community, surprise, surprise, who like to think and project the idea that they are objective and only the facts dictate their models and not the other way around. Yet Dr. Kuhn caused enough rethinking about this that today there is a general agreement that models are difficult to change. Let's examine an example historically from alchemy. Now, alchemy was kind of a predecessor of chemistry. For centuries in the Middle Ages, a lot of kings and rulers of Europe had alchemists on their paid staff with budgets to especially tackle the challenge of changing lead into gold. Lead is heavy, gold is heavy. Lead is soft, gold is soft. But lead is bad, gold is good. So for centuries, they tried to come up with a way in which they could change lead into gold, and yet they never could. The model endured. Here's another model to consider. Now, some people think that this is an electric light bulb. But perhaps it's not. Perhaps it's a dark sucker. As soon as you turn on the light switch in the room, electricity flows through the bulb, and this bulb sucks all the dark out of the room. And therefore, the room appears light. So darkness is sucked into this little light bulb, and eventually this little bulb fills up with dark and can no longer take any more dark in. This is one that has filled up with dark. That's one way of looking at it. It's interesting how one can come up with a different model that sort of explains things pretty well, but unfortunately is grossly wrong. Theories or models on the subject of origins and how nature interprets are very critical, especially on the subject of whether or not there is a God involved. If you want to notice, I want you to notice this comment by Richard Lewontin, a Harvard biologist. He said, "We have a prior commitment, a commitment to materialism. Moreover, that materialism is absolute, for we cannot allow a divine foot in the door." Materialism in this particular instance is not talking about a fancy car or some other stuff. Oh no, Materialism in the science world is the idea that material is all that there is. Material begets material, and there is no supernatural, unseen forces like a creator, God involved. That's why they cannot allow a divine foot in the door, because they want to maintain their model. They're sticking to their model. Richard Dawkins, the world-famous atheist biologist at Oxford in England, said that biology is the study of complicated things that give the appearance of having been designed for a purpose. Now, scientists will agree that these things that we look at, they seem to suggest they were designed. There's a complexity to it. They appear to be designed, but they prefer a random origin that includes a series of fortunate accidents. Francis Crick, Nobel Prize winner, said, "Biologists must constantly keep in mind that what they see was not designed, but rather evolved." They have that commitment of not letting a divine foot in the door. This worldview will absolutely affect the way they interpret data. But the human mind is such that when it looks at some objects like this rock formation, it understands random forces could have created or shaped what we're looking at. It doesn't take much imagination to expect that the wind and rain erosion will somehow shape randomly the faces of this rock, depending upon its hardness and so on. We get that random forces are at work. But when we look at something like this, can random forces form this? It becomes a little bit more complicated as we see design and structure. When we talk about the subject as the origins, it's hard to miss the greatest and most fundamental of all science question, and that is, how did life appear? Where ultimately did life come from? When you talk about life, there's a wide variety of understanding of what life even is. Here's a definition from Webster's. A principle or force that is considered to underlie the distinctive quality of an animate beings, characterized by a capacity for metabolism, growth, reaction to stimuli, and reproduction. How does that grab you? Does that adequately describe what life is? That definition is a little bit underwhelming when a mother or father holds a newborn baby for the first time. Don't you think? There is currently no consensus even regarding the definition of life. There may even be several forms of life, not just different animals, but plants and fungus and bacteria. Perhaps if life did appear, it could have appeared multiple times and forming multiple things. Probably the strongest and most obvious question of all is, how did life arise from inorganic matter? The answer to that question remains a great unknown to science. Did life come to this earth from outer space? Some feel that billions of years is not long enough for life to have come here. Maybe it came from little green men in flying saucers. Some of the greatest scientists in the world actually, believe it or not, actually believe something like this, such as Richard Dawkins, the famous atheist, who has built his reputation by arguing against someone he claims doesn't even exist. Or perhaps life appeared via a meteorite striking the earth. Or perhaps a planet exploded that had life on it, and pieces of that planet went through our atmosphere and crash landed on Earth and seeded life here. And then that life evolved into you and me. That's one view. Louis Pasteur, the famous French biologist, tackled the subject of where life came from, dealing with a theory in his day that was known as spontaneous generation, that life just simply appears from time to time in different places. He conducted a series of experiments, and he came to the conclusion there is no known circumstances in which it can be confirmed that microscopic beings came into the world without germs, without parents similar to themselves. This disproved the popular theory of spontaneous generation that led to the framing of the current biological law of biogenesis. That is, living things only come from other living things. Let me repeat that. Living things only come from other living things. However, today, modern scientists generally believe something different. Nearly all scientists believe in abiogenesis. That is, life came about via natural chemical processes from a hot chemical vent or pool, and they would disagree with Pasteur's law. And the law is something provable, whereas they're talking about historical science. Remember the differences between hard science and historical science. Hard science is testable, observable, repeatable, and predictable. Historical science is not testable, observable, or predictable. Historical science is always subject to various world views. Anyway, they're trying to imagine how something that took place in the past, how it happened. They actually tried to mimic it. Remember, because if abiogenesis happened, it was because of chemistry, long before there was any biology involved. There was an attempt to imagine how life could have formed from chemistry. In 1952, they conducted the Stanley Miller-Urey experiments. It was an attempt to recreate an environment of what they imagined Earth's early atmosphere was like. It involved gases, common chemicals, water, and electricity, simulated lightning. And it did create some simple amino acids. And for a while, this was heralded as, see? This is how life could have sprung up from some primordial soup way in the past. However, since that time, this model has fallen out of favor. Original conditions are now thought to be quite different, including the Earth's early atmosphere. But how did the basic chemicals present on Earth spontaneously arrange themselves into something resembling life? How did we get DNA? What did the first cell look like? More than a half century after the chemist Stanley Miller proposed his primordial soup theory, we still can't agree about how that happened. Perhaps primordial soup that might have had bubbles on it, and those bubbles were the beginning of cells? You know, cells are interesting things. Cells weren't really seen and identified until 1665 by Robert Hooke. He used a rather rudimentary microscope he had set up, and when he looked at them, it was the first time anybody in the world had seen cells. They reminded him of rooms at a monastery, cells. By Darwin's day, it was thought that these rooms/cells contained something called protoplasm, which is kind of a jelly-like substance. Basically, life consists of rooms of jelly in it. Things are quite different now, as biologist Michael Behe has pointed out. Now it's the turn of the fundamental science of life, modern biochemistry, to disturb. The simplicity that once was expected to be the foundation of life has proven to be a phantom. Instead, systems of horrendous, irreducible complexity inhabit the cell. Michael Behe is saying that the workings of the cell are vastly complex, beyond anybody's imagination. We could spend a whole lot of time discussing the incredible complexity that is just in a simple human cell. Actually, that's an oxymoron. There's no such thing as a simple human cell. There are 40 trillion cells in your bodies with 200 different types and functions. We're talking big time complexity. Just a couple side notes here. Did you know that there's enough DNA in your body, if linked end to end, could go to the moon and back? 127,000 times? If you're taking notes, I want you to write this down. Look up a word, when you go home tonight, Google the word kinesin, K-I-N-E-S-I-N. I'll spell it again, K-I-N-E-S-I-N. Everybody got that? K-I-N-E-S-I-N. Just Google that word. You'll see, they'll come up with a couple little video clips. Just watch the video clips. I won't tell you what it is, but you'll be amazed. It's really incredible. Okay. If there's a pothole that science usually runs into and almost never misses, it's assuming that things are more simple than they are. This makes sense from an evolutionary standpoint because the simpler things could potentially be, the easier they would be to explain as arriving from random forces. However, we don't see lots of simplicity. We see lots of complexity. Remember that first model of alchemy where they tried to change lead into gold? They thought that it would be simple, a simple process. There were so many similarities, but they assumed wrong. There is, in fact, massive complexity between different elements like lead and gold, and the idea of changing one element into another is exceedingly difficult. Now, going back to the day when Darwin arose with his theory of survival of the fittest and the origin of species, there was a perfect storm for evolution to rise in the 19th century. What were those factors? One, the weakening of the Bible's standing. The Bible had been taken apart in the last few years of the 18th century and the beginning of the 19th century with something called higher criticism. Some scholars did much studying of the Bible and tried to imagine different authors and different sources from where the Bible came, and they ended up with a picture of the Bible that it was kind of stuck together by a number of ancient writers and editors, and it really wasn't that authoritative or inspired by any God. It was just a very interesting book. That also affected the religious training, as Darwin in Cambridge was also taught similar low views of the Bible's authority. A second factor was the discovery of key fossils. For instance, the Archaeopteryx, which was that famous bird lizard-looking fossil found in Germany. It looks like a bird with the features of a lizard with a long bony tail, a claw on the wings, and teeth in the beak. It sure looked like it perhaps at one time it was a dinosaur or a lizard that was changing into a bird. And the next thing was dinosaurs. At first it was thought that there was no mention in the Bible of dinosaurs, and that seemed to suggest something very old and different in our history. Then there was the Neanderthal man found in Germany, the first caveman. It seemed like this guy Darwin was onto something. The third factor was that there was an ignorance about the complexity of genetics, as we've already talked about just a tiny bit. Life was simple with cells and jelly protoplasm. Genetics was not understood very well. Changing simple things into other simple things seemed very easy to Darwin. And finally, the growing belief that the world was perhaps millions of years old. The idea was coming from such geologists as Charles Lyell, who was beginning to imagine that the world was 1 or maybe 2 million years old. What that gave the evolutionists to work with was plenty of time. What evolutionists is key, as many writers have said, is time. If you have enough time, then lots of changes take place, and eventually those small changes add up to huge ones, and eventually you get the life forms that we see today. Charles Darwin's contribution to the field of origins was in proposing a mechanism that seemed workable. Evolution was already well accepted by many in his day, but what he came up with was something that helped that theory along. He graduated from Cambridge University, get this, as a religion major, and signed up to be the naturalist on the HMS Beagle that set sail to do a map-making tour of the world in 1831. He got back in 1836. On this cruise, as a naturalist on board, he was able to make a number of observations from his study of nature along the way. When he got to the Galapagos Islands, he noticed some very interesting things. Some of his observations would eventually become the manuscript for what would be published in 1859 as his signature work, The Origin of Species. What did he see? He went to the Galapagos Islands, pictured here, and the Beagle crew were buying tortoises to eat. The tortoises that were presented to them had different shaped shells. The locals told them that the shape of the shells shows you what island they came from in the Galapagos. That got Darwin to thinking. Surely they had a common ancestor. Then when they're on different islands, after a period of time, their shells would change a little bit and the shape became unique to that particular island. He also collected some birds and took those birds back to England. Now, not feeling that he was an expert on birds, he asked some of his friends, and eventually he was told that they were all finches. Well, how can they all be finches? Look, they all have different bills. But they were all finches. The larger billed finches were able to crunch larger, harder seeds in their food supply, and others had bills that worked in their own habitat. Yet he imagined that there might have been a common ancestor to all these finches, that some change took place to help them survive in their habitat. All of this led him to come up with a theory that was called survival of the fittest. What he saw was a natural process by which organisms best adjusted to environment are most successful in surviving and reproducing. From that observation, he proposed a net evolution or macroevolution, which is a large-scale permanent change that results in the formation of higher taxonomic groups. In other words, quite a lot of different critters. If you have enough time, little changes will add up to big changes. What he was saying is that nature was selecting the parents. When Darwin grew up in England, they did a lot of breeding on animals to get certain characteristics. They bred dogs and chickens, pigeons, horses, cows, and sheep in order to get certain qualities in the offspring. That was man selecting. That was unnatural selection. How did nature select animals? Darwin assumed nature was selecting the fittest animals. This was Darwin's world-changing book, On the Origin of Species by Means of Natural Selection, or the Preservation of Favored Races in the Struggle for Life. What Darwin contributed was a theory that explained how evolution worked. That was a necessary thing for the time because there were different theories out there. One of the theories was, maybe giraffes reaching for taller trees over the years would make their necks grow longer. That was called Lamarckism. However, since survival of the fittest doesn't change the genetic code of living things, all it does is actually make a species fit, like really fit lions and tigers and bears. And after a period of time, science began to come up with a new theory, and this has emerged as the most popular theory today for how evolution works. And that is by changing the genetic code via mutations, sometimes called neo-Darwinism. However, there are even more problems with this theory. How do mutations make new and better animals? Dennis Noble, a psychologist and evolutionist of Oxford University, said, all the central assumptions of the modern synthesis, also called neo-Darwinism, have been disproved. What's he saying? He's saying that they have disproved everything that you can do in the laboratory to test for how mutations can change genes into something that is more complex, something better, and evolving forward. All you're getting is just broken animals when you have mutations. At this point, biology is in a big trouble, and they've tried to explain this. Let me give you a simple rule to remember, okay? When you have a mutation, when you have mutations, it is always a loss of information. In order to get more complex life forms, you need more information, not less. That's a hard fact. Stephen Meyer has said the technical literature in biology is now replete with world-class biologists routinely expressing doubts about various aspects of neo-Darwinism. Neo-Darwinian theory. Rarely has there been such a great disparity between the popular perception of a theory and its actual standing in the relevant peer-reviewed science literature. The idea that Darwinian or neo-Darwinism theory is well accepted and understood in the science world is just not so. They're back to the drawing board as to what makes evolution work. There's no doubt that it happened, think scientists today, but they're just at a quandary as to how it did happen. Let's hear from experts who will explain why there is this debate on origins and where the differences come from.
Bereshit bara Elohim hashamayim v'haaretz. In the beginning, God created the heavens and the earth. And pretty much for centuries, through the Middle Ages, that was the single thought that people had about where origins came from. But then toward the 1800s, the age of reason that it is called now by science, the thought that maybe there was not an active God out there, and maybe the laws of nature was all that was in operation. So this skepticism grew about the biblical account. Charles Darwin was taught in a university, Cambridge University, that had this skepticism, and pretty soon the worldview about where we came from dramatically changed. Today we still have this debate going between creationists and evolutionists. And let's now take a look at the origin of this great debate.
To understand this, we need to go back to where science came from. It was a revolutionary new way of understanding our world. And what it did was it said, we're not going to bring all of our preconceptions into this. We're not going to let philosophers like Aristotle or somebody else tell us how the world works. What we're going to do is we're going to actually look at the world. We're going to use our empirical senses. That's our eyes, ears, sense of touch, those sorts of things. And those data that we collect using those senses, we will interpret in a logical way. And that was a very powerful tool then for figuring out what's going on in the world. But then some people added an additional rule called methodological naturalism. It said not just that we should logically interpret data and that data will drive our theories. It said those theories may not ever come to the conclusion that God was involved in any way. It can only be naturalistic explanations that we can come up with.
The idea of natural selection actually was kind of around in those days when Darwin was developing his theory. Other people, in fact, had proposed essentially the same thing. but nobody had developed it in detail and with lined up arguments and evidence and made a case for it. So Darwin collected these ideas, and he credits reading Malthus on population over population and the competition for resources, and he was thinking about nature as a kind of a competition between different organisms. And then he realized there's more organisms than there are resources. So naturally, those who are stronger would get the resources and survive. And he played off that, actually an inevitable conclusion. It's self-evident that if you have limited resources, the stronger are going to succeed better than the weaker. But Darwin's real strength, I think, was in developing a series of arguments that rested on evidence that, in fact, this kind of thing does happen in nature.
Well, I would say Darwin is certainly an icon in science. He's respected, and his contribution is perceived as really world-changing in some respects. So he is one of the holy saints of science, at the same level as Newton or other very important figure, Galileo Galilei. Now, when it comes to the mechanisms that Darwin suggested in terms of what could bring change in species or what could originate new species, when you begin to look at the granular level of the theory that he proposed, that might not be as popular nowadays. Why? Because we have so much more understanding of the complexity of life and understanding of basic things like the DNA, for example, that was not common knowledge at the time of Darwin. So he could envisage a much simpler way, in a sense, or a broad sketch of what he thought could happen, but he didn't have a clue of what was actually happening inside cells.
Today, Darwin's views are somewhat under scrutiny, but it would be helpful, I think, to kind of dissect apart his views. One of his views was naturalism, and that view is under challenge. There's evidence, maybe there's gaps in nature, that there must be some kind of power involved. And of course, the intelligent design movement has used that and developed that argument that in fact there is something more than just nature. Another view of Darwin is that natural selection can account for varieties that adapt to local habitats. And I think virtually everybody accepts that. Then Darwin's view that microevolution, if you want to call it that, this natural selection of small changes, that accumulates over time to eventually produce macroevolution. Well, scientists have held to that very strongly because they were afraid to give creationists any kind of a foothold. But as time has gone on, the scientific community has kind of gotten wary of that argument, saying, no, we don't see this is going to work. For example, if it's advantageous to have a longer tail, well, you can get that tail longer and longer and longer, but you're never going to make a wing out of it. How do you get a new organ? Microevolution just is not going to add up to a new organ. Plus, looking at the fossil record, you do not see that in any way. Looking at modern experiments, you do not see that in any way. It just doesn't work. So at the present time, the scientific community, the evolutionary biology community, is looking for ways to explain macroevolution. So far, they haven't found one, but there's many, many, many of them that recognize that Darwin's theory doesn't cut it. Another aspect of Darwin's theory is common ancestry. And I think for the most part, common ancestry is still accepted without empirical evidence, I would say, but as a necessary conclusion from materialism. If you're going to have only natural processes, you're not going to have different kinds of animals popping into existence all over the place. You're lucky to have it once. And so if you have once, then maybe you can play with it from then on. But common ancestry is one I think is weakly supported, but it's necessary for naturalism.
The people who are molecular biologists and who are experts in the field of how genes act and how they function and whether or not genes get duplicated and what bacteria do with extra DNA if they encounter it. Those guys are often working on particular problems. They're trying to solve cancer. They're trying to come up with a way of dealing with COVID. They're trying to solve a particular problem. And then you have another group of people over here who are trying to show that evolution is true. And they'll hypothesize about things that happen with DNA, these massive gene duplications that then resulted in new functions. But they never actually check their hypotheses with the people who actually know what they're talking about in terms of molecular biology. So there's often not a whole lot of crossover in between those fields, the theoretical evolutionary biologists and then the ones who actually are where the rubber meets the road. So I think sometimes hypotheses get generated about how these processes could have taken place that are not necessarily in line with what even evolutionary molecular biologists would have to say. So there's sometimes a disconnect there. So that's the main way. They just ignore it often. The people who are working in problem-solving areas, evolution obviously took place. Have you thought about it? No, I'm busy trying to solve cancer. These guys down here, evolution obviously took place. Well, have you thought about it? Yes, I'm thinking about it very carefully. I think that this happened and this happened. Well, but that can't happen. Well, don't dissuade me with the facts, ma'am. So sometimes there's a lot of what are called in the literature just so stories, that this must have happened this way. Do we have any proof? Maybe, but there's no it happened in the laboratory.
Worldview are kind of like glasses. That's one of my favorite illustrations. But the glasses, everyone has a pair. Some people aren't as aware of their worldview as others, but basically it's the lenses through which we interpret life. Worldviews are really helpful in what we would use them to answer the big questions. Does God exist? Does he or doesn't he? However you answer that question determines a whole lot of direction of where you're going to go. Where did the world come from? What does it mean to be human? Is there life after death? Ethics. Why are some things right or wrong? And then maybe another question might be, is there a grand overarching story that gives meaning to existence or not?
So what we think on the subject of origins is entirely shaped by our worldview. And does your worldview include a picture of a large and powerful and caring and capable God? Is he able to give us a record of what's taken place at the beginning? Does he care enough to think we actually would like to have that record? All of these things affect how we view the data, how we interpret the data through the filter of our worldview. Let's begin to take a look a little bit more now about some of the positive images that Scripture holds about the God who created us.
More scriptural view of these subjects. It's interesting that materialism says that everything is made out of material and only visible forces are involved. That's against the Bible view that says there are other forces out there. By faith, we understand that the universe was formed at God's command, so what is seen was not made out of what was visible. Here we have a view that's definitely not materialism. There's another force out there, and we call that force God. I'd like to share with you a story that has to do with the famous Apostle Paul and his encounter with early science philosophers. These were people that he met in Athens. And ancient Athens is where many people believe that Western science had some beginnings, some foundations were laid there through the philosophers questioning the old stories about how the gods created and made everything. Instead, they began to observe things and then think a lot. And then they talked a lot about what they thought. The Apostle Paul came to Athens on one of his journeys. He was alone waiting for his companions to catch up with him, and he met some people in the marketplace, and he started a conversation. It went something like this. Now, while Paul waited for them at Athens, his spirit was provoked within him when he saw that the city was given over to idols. Lots of gods and lots of temples. Then certain Epicurean and Stoic philosophers encountered him, and some said, "What does this babbler want to say?" Epicurean philosophers followed a great thinker called Epicurus, who said that the gods are not involved in the world. They're too busy having fun. Mankind should be like, don't worry, be happy, have a good time, go out there and party. Oh, and by the way, there's no afterlife, according to Epicurus. The Stoic philosophers followed Zeno, another great mind in the ancient Greek past, and this is what he said, something a little bit different. God is in nature, not above it. Man's happiness comes from overcoming wrong attitudes through increased knowledge. In other words, study to show yourself approved, grow your brain. That's the way to live. Oh, and by the way, there is no afterlife. So the one area that Zeno and Epicurus agreed was that there was no afterlife, but Paul talked about such a thing. Others said he, Paul, seems to be a proclaimer of foreign gods because he preached to them Jesus and the resurrection, about life after death, which these science-oriented people doubted. So they took him and brought him to the Areopagus, this hill pictured on the right, saying, "May we know about this new doctrine of which you speak." Now, Paul was a very educated man, and he said, he stood in the midst of the Areopagus and said, "Men of Athens, I perceive that in all things you are very religious. For as I was passing through and considering the objects of your worship, I even found an altar with the inscription, 'To the unknown God.' Therefore, the one whom you proclaim without knowing him I proclaim to you." What's he saying is that even you admit that you don't know all that's up there. There may be other gods, and so let me tell you about a God that's up there. God who made the world and everything in it, since he is Lord of heaven and earth, does not dwell in temples made with hands, nor is he worshipped with men's hands as though he needed anything, since he gives to all life, breath, and all things. We ought not to think that the divine nature is like gold or silver or stone, something shaped by art and man's devising. Truly, these times of ignorance God overlooked, but now commands all men everywhere to repent, because he has appointed a day on which he will judge the world in righteousness by the man whom he has ordained. He has given assurance of this to all by raising him from the dead. And when they heard of the resurrection of the dead, some mocked. Now, these are science-oriented people. They could not imagine anything like that. That's a miracle which is working against the laws of nature, and some mocked. After all, a being who made heaven and earth, a creator who gives and actively maintains all the life of all creatures, he's that involved in our life days to day? Someone who can't be contained in temples nor properly represented by man's reason or art? In other words, any graven image that we can think of or any concept in which we can try to box God in is going to be insufficient, for he is far greater, far above anything we can conceive, because he is God. He made everything. A divinity above natural laws and fully capable of suspending them at will? That means raising people from the dead. A God to whom we are responsible? All these questions were a challenge to their thinking, their way of approaching this. Their worldview was being challenged. Some mocked. Their paradigm needed to shift. However, some believed. And they went through what we would call a paradigm shift. Their worldview changed as now they had a better explanation of everything that they saw around them, that it was created by a creator God. Alistair McGrath wrote about Richard Dawkins, his colleague at Oxford University, and his atheism. Alistair shares his own story where he said, "Although I was passionately and totally persuaded of the truth and relevance of atheism as a young man, I subsequently found myself persuaded that Christianity was a much more interesting and intellectually exciting worldview than atheism." Can one be a creationist and do good science? We've read a number of statements doubting this possibility, but this is Wernher von Braun, who was at one time the head scientist of NASA. If there is a single person most responsible for putting man on the moon, it was Dr. von Braun. Notice what he said. "Religion and science are sisters. One seeks knowledge of creation, the other of the Creator." Yes, so absolutely, one can do good science. You and I can bring science and religion together and still get the work done. It's not either or, but both and. And this is a very different and complex and even perplexing story. It might mean you're going to have to make a paradigm shift, but it's possible. For many of us, we've been led to do just that, and it all makes sense. Thank you. Well, friends, we're off and running. Tonight was just the beginning. Come back tomorrow night as we look at the origins of humankind. Now, I know you might be thinking, I could have skipped, if you were going to skip a night, tonight would have been the night to skip, okay? But you don't want to miss tomorrow night. Trust me, you're going to love it. We're going to look at the origins of where you and I came from. Thank you very much for coming. I appreciate it. Pastor Lou.
So before we close tonight, let's have a word of prayer. Father God in heaven, again, we want to thank you for the presentation that was given tonight. We want to thank you, Lord. It was a lot of information and a lot to take in. But Lord, I want to thank you again for being with Ron. We ask now that as we depart from this place, as we go our separate ways, get us home safely. And Father, I pray that we will come back again tomorrow evening at 6:30. And Lord, I pray that maybe we'll even bring a friend, bring a spouse, bring a family member. And again, Father, tomorrow night is a very important night. So I pray that each one will be here and more. In Jesus' name, amen. God bless you. Have a wonderful evening. Drive safely.